Hi there everyone. Can you see me? Can you see the screen? Hello. Hello. Are there guys there? Hello. Are you all there? Yeah, fine. We have few viewers joining in. Some will join late, some will join early. Like that it will go on. So today we are gathered over here to discuss about Cauchy integral formula. Okay. So Cauchy integral formula, or you can call it Cauchy integral theorem. That is the main point of discussion of today's lecture. So we will see that within a few moments as few students join in, and then we will begin. We'll wait for a minute or two and then we will start. So we will start in a short while as we just check the setup and all join in. So we shall start in a short while. Okay. So those of you are joining in, do text there. I'll. So it's good to have at least some conversation in between it. Now this live session, I would think that if we can have all people, those who are joining in, and they can also uh, talk or interact, then it would be good. Just like how there's in a class. But this is just live, one way we are interacting on the comment section, and that's it. Okay, so yeah, for those who are just joining in, we will hold on for some time. We will soon begin with the lectures, uh, the lecture part. Hold on. Just I'm waiting for few people so that if you are there online, let me know. Just say yes, hi, or something in the comment section so that I can, you know, begin the whole thing, and we can at least come to know there are people out there who are watching us and who can help us to, you know, help others. That's how it will work. Okay, now let us begin with the main part. Today we are going to discuss regarding what is called Cauchy integral formula and Cauchy integral theorem and all that stuff. So this is lecture is on Cauchy integral formula and then theorem also, but then I'll just help you out how does it work. This is the short lecture on Cauchy integral formula and its version. So let me give you that formula. That will be very helpful. Now I'll write the whole technical statement first so that it benefits everybody, because this is the main statement from which the theorem understanding has been developed and furnished. So we will first write down the statement. So with all due respect to that statement, let us write down. The statement is a different version the way it is given, but the way it is used into the solving part, it is slightly different. So for we will first write down the statement. If f of z is analytic inside and a closed inside and on, right, inside and on a closed curve. Now see, I am using curve C, but if you are in pure mathematics, or if you are studying pure mathematics, most of the people would be using the word gamma. Okay, they like to use this different tough notation. So sometimes they use gamma curve in pure mathematical world. Everywhere it is called gamma. So that's what they do. So don't worry, we will call it C. But yeah, so just to get used to that thing of a simple, of simply connected region R, and if Z naught is any point within C, then the formula says then f of Z naught is given by 1 upon 2 pi I integral over C f of Z divided by Z minus Z naught dz. This is the formula which by statement is given to the crowd, but the way it is used is slightly different. So there is an alternative version over here. I'll give the alternative version. Alternatively, it is integral f of z over z minus z naught. You take this 2 pi I onto the other side, so you get 2 pi I f of z. Okay. Here dz you need to write. This is dz over here. So this is the alternative version, and this is the usable version of the formula. Okay, the most usable version of the formula. The other one is also useful, it's not denied, but this is how people use it. And over here you will have z naught. Okay, 2 pi I into the function evaluated at z naught. This is the main formula. So we will see how to go about it, and let's do it further. Hello, hello. I think people are not able to join. I don't know what has happened. So those who are interested, they will join later on, or they may see the recording or the other version, whichever suits them as per their convenience. That's how this online works. But yeah, fine, no problem. We can have those who ever want to join, they can join. Okay, so fine, no problem. We will complete the whole work. Cauchy integral formula is, this is the statement and the alternative version I have given you here, and I have shown you the usable version, that this is how it is used to solve. Now we will see examples, but one more version of the same formula is there, which is called as Cauchy's integral formula for derivatives. It is the generalized version of the same. Okay, so I'll give you that version also. So this is called Cauchy's integral formula for derivatives. This is how the formula. Now it is like this: integral c f of z over z minus z naught to the power n dz, okay, which is equals to 2 pi I over n minus 1 factorial. Okay, then there is this thing is there, the n minus 1th derivative of the function f of z evaluated at z equals to z naught. This is what is the formula. And again, the conditions, what is f of z and what is z naught, they are just the same conditions which are there in the Cauchy integral formula. Okay, so z naught is again any point within the C. Now there is one very important thing over here, which is we have to be very careful about the format. So there is a note, so or note, or I would say caution: always check the format before using Cauchy integral formula. Okay. You have to bring the question into the format which is there, and then only you will be able to apply the formula. This is very important, otherwise there can be problem while solving the questions in the examination. Now let us start taking up the question. If any one of you are there online, can I have just a short hi hello thing in the comment section? Who all are there online? I don't even know. Hello. I'll just write hello. The whole purpose of my live lecture is that those who have missed out, those who have not been able to attend any places, or this those who have been waiting for a long time, they can get what they wanted through the video lectures. Okay, so this is the main part that I wanted to deliver, and this is the most important and one of the most trickiest topic that can have happen in Cauchy residues and all this. Okay, yeah, so let us go ahead here. Now we'll take up the question. The formulas are over. Okay, the formulas are over, and we will now go for the sums. Okay, the questions we will take up, and we will see how to handle the questions first. So let us see how to handle some basic questions, then we will jump upon the tough questions. So let's do this. Question number 1. Simple question is that they are asking us e raised to z over z minus 4 over the curve c dz is there, okay, where c is mod of z minus 6 is equals to 3. Evaluate using Cauchy integral formula. How can we do this question now? That is our question. So let us see how to handle this. So again here the steps are very simple and very straightforward. Okay. Step number one, you have to check the denominator. The denominator has to be in the format of the function. The format that we know is this one. Okay, please be very careful. The format of the formula that we know is integral f of z divided by z minus z naught. Sorry, f of z over z minus z naught dz. This is the format of the formula we know, and that is 2 pi I f of z naught. Now, according to this, we have to also check that this z naught should lie, z naught is lie inside the circle C. We have to check this. So now let us do that. So here we have here z minus 4 is equals to 0, implying here let, if you say here let z minus 4 equals to 0, we will do that way better. Here let z minus 4 equals to 0, implying z equals to 4. So therefore z not equal to 4 we will write directly. Now z not equal to 4. Now to check, z not lies inside C or not. How do we check? So how do we check this? So we will first now write here z naught minus 6 when we consider. So it becomes 4 minus 6, which is mod of minus 2. Mod of minus 2 is 2, and this 2 is less than the radius 3. Okay, therefore z naught lies inside C. That is, yeah, I'll just write that much only. Z naught lies inside C again and again, otherwise lengthier expansions. So now we will be using the formula. Okay, so let us use the formula. But before using the formula, we have one very important thing here. We have to detect in this, while using Cauchy integral formula, we have to detect what is f of z. Okay, so here to detect, so like find f of z, we have to find this f of z. This is a elementary step, but it is an important step. Okay, find f of z. So what is f of z in this case? It is the numerator. Okay, remember here f of z is equals to e raised to z. Therefore now we have found that. Now at z naught we will evaluate. So f of z naught is equals to e raised to z naught, that is e raised to 4. Okay, now we write down by Cauchy integral formula our answer for I. So I, whatever is the question, okay, this I which is there, our answer is going to be integral e raised to z over z minus 4 dz. The original question will become 2 pi I times the f of z naught. It is 2 pi I, okay, 2 pi I times e raised to 4. This is your answer. That's the only thing that you have to remember. I don't know, like, let me just see, like, is it visible? Because I have written at the very bottom of the page. So, yeah, e raised to 4. This is the answer. Did you get this? Please hit like or let me know in the comment section that you have followed it. Once you have followed, I'll move ahead with the another example. Let me know in the comment section that you have followed. Just hit like or let me know yes or no, something I can do further. Okay. Yeah. Am I audible? Hello. Am I audible? Hello. Am I audible? Yeah, I think my mic is working, so that is there. But hello. Yeah, I don't know. I don't get that. Anybody is not there. But it's fine. Not a issue. We will see this further. Now we take up another example. What will happen? Let's see. We take up another example. Now in this example we will go for a little harder a question, so that we or a different kind of a question. See this. Now what we will see this in this question, again this question is very nice and a very different type of a question. So here we are given this integral sine z divided by 2z minus pi over c dz, okay, where c is equals to mod z equal to 2. Now this is the question that they have asked. So we want to find this answer using evaluate using Cauchy integral formula. Okay. Now while evaluating using Cauchy integral formula, what are we going to do? Here it will work like this. Firstly, we will write I. The given question, what is there? Here we write this sine z divided by 2z minus pi over whatever that c. Okay. And now see, our format of the function is f of z divided by z minus z naught. So I want over here z minus z naught format. So z should be alone, right? Rather, only coefficient of z can be 1. So if that is the format, then I will have to take this 2 outside. So I will have 1 upon 2 integral sine z divided by z minus pi by 2 dz. So now I can say that here z naught is equals to pi by 2, okay, and my function will be f of z will be sine z, okay, and I have to now check that this z naught which is pi by 2 whether it lies inside the circle C or not. So how do I check it? So we will check that answer whether it is inside the circle or not. So mod pi by 2, or rather mod z naught, if I write, it will become mod of pi by 2, which is pi by 2 only, and this pi by 2 is 3.14 divided by 2, so which is obviously less than 2, right? So this is less than 2, hence here I write, hence z naught, which is pi by 2, lies inside C. Having said that, what now we do is write the we use the Cauchy integral formula. Now see, when we use Cauchy integral formula, it will be used only for the term which is there inside this yellow bracket. 1 by 2 will remain outside the bracket. Okay, am I clear about that? So we now write, therefore by Cauchy integral formula, by Cauchy integral Cauchy integral formula, integration of sine z over z minus pi by 2 dz is equals to 2 pi I into f evaluated at z naught. So here it will be 2 pi I into f evaluated at z naught. It will be sine pi by 2. Okay, sine 90 is 1. Okay, so here my answer is 2 pi I. But this is not the complete answer. So the complete answer for the original question I, it is going to be 1 by 2 multiplied by the value that we got. Okay, 2 pi I. So the final answer is pi I. I hope this is clear to all of you.
Hello, am I clear? Hello, am I audible now? I don't know. Hello, yeah. So now what we will do, we take up another question of similar nature. so that we will be able to get the hold of the concept. So let us see another question. So this is the third question we will see. Now see, the questions which are there right now, they are very much basic in nature for the formula that we are seeing. So let us see another basic question like this. So let's say this is integral sine 2z divided by 6z minus pi dz, okay, and where c is mod z equal to 3, and we have to evaluate using Cauchy integral formula. So how do we do this? In this case the answer will be like this: 6z minus pi. So what will happen here? 6z minus pi, you let it equal to 0. So here z is equals to pi by 6. Okay, so you let this, therefore z naught is pi by 6. This z naught being pi by 6, we will now check whether it is inside the circle or not. Okay, so we have to check that z naught, mod of z naught, which is mod of pi by 6, and mod of pi by 6, when you do, this is 3.14 divided by 6, it is obviously less than 3. Okay, therefore you claim that z naught lies inside C. Now when we have claimed it is inside C, we now detect the function f of z. F of z is sine 2z, numerator. But remember that we will also have to change the format of the question. It is I is equal to integral sine 2z divided, now as I said, 6z minus pi. So this z should become alone, rather it should have the coefficient 1. So I can take 6 outside. Okay, this here when you write, this will happen like this: 1 by 6 taken outside, sine 2z divided by z minus pi by 6 dz. So over here, now this is going to be 1 by 6. Now the answer for this portion, the yellow, I'll put it into a bracket. So for this yellow bracket, it will be 2 pi I times the function evaluated f of z naught, evaluated at z naught. So what will happen in that case? In that case we will have I equal to 1 by 6 into 2 pi I into sine of 2 pi by 6. Okay, so here it will be 1 by 6 into 2 pi I into sine, it will be sine of pi by 3. Sine pi by 3 is sine 60, right? Sine 60 is nothing but root 3 by 2. So 2 pi I divided by 6 into root 3 by 2. 2 and 2 gets cancelled. You can write your answer as root 3 pi I by 6. This is your final answer on this. I hope you followed this. Okay, those of you are there, you can hit like or let me know whatever your comments are there and whatever your views are there. I would be happy to guide you on that. So this was a very basic and a easy level example on Cauchy integral formula. Now let us see some tricky and a difficult example in which some points will be lying inside the circle, lying outside the circle, and something like that. Now see, in each of the case, the first case was a very simple one in which the point is inside the circle, but the there is this format is az minus b. If we consider, then a is 1 and b is any other number. Okay, this is the case in there. Okay, here this is the case. This is case 1. Now here it is not 1, that a is not 1, so we have taken that number outside and we have seen how to handle it. This is the two examples we saw on that case. So now we will see another kind of example in which things are slightly different. Let us see this example. Question number 4. Here I is equal to integral 1 plus z into e raised to z divided by z square minus 3z dz. Okay, this is C, where mod z is equal to 1, and you have to find I using Cauchy integral formula. Now how to do this question here? So firstly we will write here step. The first step in this case, when such a kind of thing will be there, you have to let the denominator equal to 0. Let z square minus 3z equal to 0. Simplify it. Where does the denominator become 0? So the denominator becomes 0 at z into at z equals to 0, and here you have z equal to 3. These are the 2 points you will get. Now, so this is z not equal to 0, or I'll rather write here z1. Okay, I'll write here as z1 is equals to 0 and z2 is equals to 3. Now we check which point is lying inside the circle. So which is obvious here that z1 equals to 0 lies inside circle, inside C, that is mod z equal to 1, and z2 equal to 3 lies outside C, that is mod z equal to 1. Now comes the most important thing, very important part, how to handle this. This is the most important and the most confusing part for many students in the examination, where they make mistake. Okay, so let me help you out with that. How does this happen? See, what you need to do, you write your I, which is given to you. So it is 1 plus z into e raised to z over z square minus 3z. We write this, and now comes, first you simplify the denominator and write the factors, z into z minus 3. Then what comes into the picture is that we have to keep, remember this. Okay, I'll write here in words, I'll give you over here, or yeah, just here. So we have to keep we have to keep only those terms, only only those term nahi, only that term, rather only one single term will be remaining in the denominator. Only that term in denominator whose, or who, or you can consider that makes denominator, who is, rather I'll write like this, who is inside the circle. Okay, who is inside the circle, that is what you have to remember. Now, uh, here we can see that factor will remain, that is inside, and here you can write all are rest all are part of numerator. Remember that. So who all will remain in the denominator? In denominator now I will have only z. Then where other terms will go? All these terms which you see, these terms are part of numerator. So basically what they are trying to tell us is 1 plus z into e raised to z upon z minus 3 dz. This is what they want us to understand. So now here I am in a position to say over this whatever c. Okay. So now here I say, hence I say a very important line here, f of z is equals to 1 plus z into e raised to z over z minus 3. Therefore now I evaluate this at z naught, or z1, sorry, at z1. We have written it here z1. So evaluating it at z1, we will get, what do we get? Z1 is 0. So 1 plus 0 e raised to 0 over 0 minus 3, we will get here 1 upon minus 1 upon 3. This is the value of the function, and therefore what we will do now, by Cauchy integral Cauchy integral formula, what will happen? I is equal to 2 pi I times f of z1. So this is 2 pi I times minus 1 by 3, that is going to give me minus 2 pi I over 3. This is the answer. Okay, I hope you have followed about it. Okay, now we go for the next part. So the next part over here, we will take up similar question in which we get one point inside and another point outside, so that our understanding regarding the concept becomes stronger. Let us take up the following question. The question is, evaluate using Cauchy integral formula I equal to integral z square plus 3iz minus 2 divided by z square plus 9z, okay, dz. This is the question. Now, and c is mod z equal to 1. How do we handle this? So again, the same process we will follow. Let z square plus 9z equal to 0. Therefore z into z plus 9 is equals to 0. Now what happens? Here z equals to 0 or z equals to minus of 9. So z1 is 0 or z2 is minus 9. Now which one lies inside the circle? It is obviously z1 equals to 0 lies inside C, and z2 equals to minus 9 lies outside C. So what will happen now? We will see what is happening with f of z. Okay, so obviously now we will have to write I. Okay, so we write I over here. So the I value is going to be integral z square plus 3zi minus 2 divided by z into z plus 9 dz, and I will now be able to write only that term. I have to write whose denominator is lying inside the circle. Now we have seen that z plus 9 gives z equal to minus 9, which is outside. So this portion, okay, this full portion will be in the numerator of our integration. So therefore integration z square plus 3z I minus 2 over z plus 9, when you write like this, you will get denominator, at the main denominator there will be z. So our function f of z has become, hence here f of z is equals to z square plus 3zi minus 2 over z plus 9. So this function is to be evaluated at z1. So what do we get here? It is z1 is 0. So that is f of 0. What do we get here? We will get here minus 2 by 9. We will get. And hence, so by Cauchy integral formula, by Cauchy integral formula, I equals to 2 pi I times f of z1. This will give you 2 pi I times minus of 2 by 9, and that is minus of 4 pi I by 9. That will be your answer. So this is how the questions on Cauchy integral formula are solved. Okay, so I hope you have followed these examples. I have taken on in about 5 examples in this. Okay, this is the 5th example. So I hope that has helped you and benefited most of you across. Okay, so thank you for joining in, And this is all that I would be uh, dealing right now. I will see you with difficult examples in the next video lecture on this. If you have any comments or queries regarding this session, you can let me know. I'll give you a few practice questions so that you can try on your own, and so like your brain is active for the entire session, and you can relate yourself to this. So you can try these on your own. The first one is integral 2z over z square plus 3. You can try this, that's easy. And dz, I'll give you the circle, which is, let's say the circle is mod z is equals to, oh, all right, I'll change the question other than 3 and all that will give you difficulty. I'll reduce the difficulty level to something more. You can take down like this: 2z plus 1 over z square plus z. This would be very easy, where mod z is equals to half. That would be helpful for all of you. This is very easy question. Second one you can try on your own is z over z square minus pi square dz, where c is, this is c, is mod z is 3. Another similar version I'll give you, if that's all are easy. You can try the following, again very simple question. Here you can try this. If this is not a difficult one for you, then you can try this one: cos z over 3z minus pi dz, where c is z equal to 1.1. Very straightforward and easy. Okay. Yeah, these three kind of questions, if you try, I believe you will build your confidence regarding the topic, and that will help you to boost your thought also, okay, on this topic. And yeah, you can use Cauchy integral formula. Very easy questions. I hope you benefit from this. The next live session we will see the answers of these. Till then, thank you, and I hope you have benefited from all this. If you are there, you can let me know your views in the comment section. Yeah, not many are there today. Maybe they are busy with their work and everything. Yeah, thank you for joining. So we will be ending the stream soon. If you have any doubt or difficulty related to it, let me know. I would be happy to guide you on it. Thank you. I shall be stopping now the stream. Thank you so much for joining.